So recently I've had some questions about wrap and the surfacing tools inside of wrap. So most people, when they look to purchase wrap, the way we position the product primarily now is selling it for scan processing, scan cleanup, and then secondary um, fitting surfaces to the geometry. And then a third reason why people tend to pick up wrap is for its scripting capabilities and the access that we give you to the code to be able to write your own software kind of on top of wrap as a platform or using wrap as a component of your software. So that scripting is another option. But again, going back to polygon cleanup is one thing, but surfacing, I get lots of questions at because the way surfacing happens in here is very powerful, and many people in the past have used it quite a bit. But recently, people uh, have fallen off the radar as far as the experts on this. So I wanted to give some tips and tricks as the different styles of surfacing that I use on a regular basis inside of wrap. There will be other things outside of what I cover here, but I'm just trying to use a very simple model that can show some different strategies to surfacing objects inside of wrap. So the first thing you're going to do is I'm going to take this mesh model and toggle over to the exact surfaces tab and hit exact surfacing. When you do that, it kind of converts that object over to an exact surfacing object. It's still a polygon, but it converts it over to that exact surfacing object to work with it. It's kind of a platform thing. From here, there's two different main routes you can go. One of them is the auto surface route, and the other one is manual surfacing route, which is everything here. And then at the very end of the line here, you can convert it back to a polygon again. So real quick, the auto surfacing, everybody knows we're famous for this. One thing that I like about our auto surfacer is this interactive mode, which is really neat. So if I go ahead and run auto surface, we're basically telling it this is a mechanical part or organic part, which I just left it on mechanical. It's just two different approaches, giving the software more or less flexibility to try to make structured patches and how it defines the patches and stuff. You can run either or, it doesn't matter. But the interactive mode, I kind of selected this one on purpose because interactive mode will find more things if I try to run mechanical on this part. So here it says, we found some patch problems. There are 16 of them. Do you want to fix them manually? So with interactive mode, just like the term infers, it'll stop in process, and this walkthrough mode down here is really neat. It'll allow you to come in here and say, I will drag that point over there. So now there are 14. And you'll see here, you can kind of sort out some of these problems along the way. And again, some of these problems are basically caused because I selected an algorithm that specializes in a different type of part. But again, part of the reason why I did it is so we would have something to fix here. But mainly, these are the things that it will find are poor patch angles. And many times the patch angles aren't really that big of a deal. Now, obviously in that one, that specific case right there, it's going to have some like surface wrinkles. So if you think about surfacing like upholstery, I always use this term. You're kind of like taking square pieces of fabric and wrapping them around the shape of this polygon. And if you're an upholsterer, you can wrap them in a way that will cause wrinkles, right, in the surface. And that's kind of what happens here because you have only square patches. That's defined by NURBS. And the patches, if you don't lay them out properly and you stretch them in different directions, you can kind of cause wrinkles as it tries to fit to the underlying geometry. So I'm not going to go ahead and fit all these, but I can just say, hey, those are the ones I want to fix, hit done, and then it will finish out the surface. And it will go ahead and finish calculating. So now that it's done, you can see kind of what I mean. If you leave certain things. Now this part has texture to it on purpose, like it's just a piece of clay that we sculpted to use this as a sample. But you can see what I mean, how you can have wrinkles if you leave certain things in here. And then some of those are in the texture anyway. So that's auto surface, right? I'm just going to convert that back, not preserve my patches, and go from there. So that's one method, is using the auto surface command. That's the most famous one. I think most people understand it. After that, you can go down the wormhole of manual surfacing. So I'm going to show a couple different methods of how I would go about manual surfacing something. Just depending on how much time I have and how closely I want to follow the mesh, and or how much time I really want to focus on structuring the patch panels and stuff. So by default, I kind of run, you can run this detect contours, and this tool will kind of compute the areas of high curvature and allow you to draw with paint on the surface, like where you want it to draw curves and stuff, and you can kind of massage the paint and draw where you want those red lines. Now wherever the red is, it's going to fit curves, and I'll do that. I'll extract it just to show you. See what happens there. Wherever you draw the red, it'll draw curves, which will then define those panels. That's not my favorite way to do it. I tend to just go ahead and draw them manually, especially on a part like this. This is purposely chosen. This part is purposely chosen. So I can come in and quickly draw on the surface of the mesh. So you see I just drew a curve there. And if I keep drawing and I change directions drastically, it'll automatically put an endpoint there. If I don't, you'll see that it creates like continuing points, and I'll show you here in a second. So I just drew that square. The dark red are end points, and then these lighter orange are the midpoints on the spline. Now you can, this is a sharp corner, but I can click and drag from one to the other, and I can make that a tangent one. And you can actually see the tangency if you turn on this collinear contours thing. Now if I just drag it back and make it sharp again, there you go. So there's all kinds of little shortcuts in here to do this quickly, but I'm just going to come through, and you can make things follow the flow line of the shape of the part if you want, or you can just go straight across like this if you want. It's all up to you and how you want to surface the part. Some people prioritize having the structure of these patches to be straight on all sides, right? So with this, you can then click and drag. Now, if you wanted to, you can add extra resolution, extra panels on each of these sides, and you'll see here what happens. As I click, it'll break up these into different points, and I can come in. I'm just going to show this as an example. If I want to draw an internal piece, and then I hit escape, and then I draw another piece there and hit escape. If I wanted to break this, I could just come in here and click and create another one and connect it, and you could just come in and create all kinds of structure depending on how much resolution you need to preserve. So the one question I feel like most people will ask is like, why do I need to draw that many, right? If you draw more, you're going to have more resolution. So right now it's going to fit patches inside of here, and you can add patches or subtract patches, and then that will give you more or less definition. Now, if you have some of these points that you don't want, you can hold Control and remove these from the different sides, or you can add more of them and kind of drag around and follow the flow line of the geometry. And you'll see there what I accidentally did is you can click on the entire line and move it if you want. And then one other thing I'll point out, I'll just create a scenario where this happens. If I have this arc all the way around, that is one line connected with these ends here. But if I want to take this and I can remove a point there, or I can actually convert that to a point by holding shift. So if I can convert that to a point, a anchor point. So now what I just did there is I made this four-sided. And then if I just drag these from side to side like that, now I've created sharp contours. Reason why that's important is these patches have to be four-sided according to how NURBS surfaces work. So what this is going to do is fit a one, just pretend this is a panel or whatever. You want to try to create four-sided patches. Now, yes, we can fit inside of those patches and we can shuffle patches, which I'll talk about in a minute. But this is just the concept of trying to lay out a part and create, and I'm holding control here to get rid of these lines, to create four-sided patches. And you try to get rid of these guys too by holding control, because it makes your life easier, because that is a constraint of how NURBS surfaces work, is that they are four-sided. Now, in CAD, you can trim four-sided patches to each other, and it defines another edge and all that, but the accuracy and how that works is different than how we utilize it here inside of this software. In this software, we're connecting all the patches together into a network of four-sided patches. So here I'm going to go ahead and accept those contours. The next step in this method that I'm going to show is I've drawn out my contours. I'll just go ahead and say, construct patches for me. And I'll just tell it to auto estimate. Just go ahead and fill all those panels that I've created, all those contours, with patches. And I'll just take it a second to do. And because we laid it out so structured, it did an amazing job. I mean, that's pretty structured, but it's not perfect, right? So this is where shuffling comes in. And you can do a whole class on shuffling patches, but I'm going to try to cover the basics of how this works. So shuffling patches, the way it works is you turn on this tool, you click on a panel. The first thing you need to do is define the corners by clicking here and on all four corners. They are already laid out properly on mine here, but I'm just showing just to show how I would do that. I select my four corners of my piece of fabric that I'm going to drape over the edge of this surface. That's the way I think about it. And you'll notice it runs the calculation. It says, this is the reason why we have this little joint over here, is it's got 8, 8, 8, and 10. So you got a decision. You got to make these across from each other the same, right? Or you can leave it like this. You don't have to. It's just going to put these little T-junctions in there and go from there. But so I got the decision. I can add to this side or I can subtract from this side. In order to do that, I click on this add or remove. So in this instance, I'm going to say I want to remove from this side. I accidentally clicked add, so I have to hold control and it will remove, control, and it will remove. So now I've kind of messed up my panel, right? But I do have 8 on all sides. Now if I go ahead, it's got this different type. Right now I have it set for auto detect. I'm just going to tell it to fill the interior of the structure, the pattern, with automatic detect. And I'm going to hit execute. And we'll freeze up here. So the idea now is I need to hit execute. So what it's telling me is it went ahead and fixed this and made it nice and structured, but this panel next door now has issues because we changed the amount of points on the edge. So this is where this interface comes in handy, is you can hit next and then you click on another panel. Now you'll see that it has, the corners aren't messed up. So you have to define your corners. So, And now you'll see we have 8, 8, 8, and 10, and we made the decision that we're going to subtract. So I'm going to hold Control and remove 2 and hit execute. It'll just recalculate, and then we're still going to need to, even though we didn't cause an error, we hit next, come over here, and define the corners, and remove. So 8, 8, 8 all the way around. Next, and then we're going to shuffle this last one too. There. So 8 all the way around. Sometimes it just needs a shuffling where I just click on it. They're already defined, and I just hit execute, and it will actually grid it out better. Now this is where this comes in handy. If it gives you a pattern that you do not like, you can actually change these different algorithms where it will go grid, strip, circular is really weird. Watch. This is when you're at the top or bottom of a part. That's where that's handy, is if you're like a cylindrical part and you need to go all the way to the top or the bottom. That's where that's handy. So that's the basics of shuffling. Now there's a lot more in here that you can do. You can come over to edit, and I can just click and drag these points and move them all around. I will say that generally, if you lay out, this is how surfacing works best. If I lay out my contours properly, I have a lot less work shuffling. So that means I don't have to dive into all of that. If I lay out my patches properly, I don't have to edit my grids or surfaces at all. So the idea is you got to get this first stage right where you structure the outer boundaries of these contours. And then from there, everything else goes smoother. So everything else will go smoother down the line. So now once I'm done shuffling those, I can go ahead and say I want to fit my grids. And you can say what resolution. This is default. If you want to capture more resolution, what it's going to do is say that the grids are going to be 20 by 20. So each one of these panels will have 20 across. So you see, that's a kind of high resolution. But most of the time when people are surfacing, that's what they're looking for, is that high resolution. And then fit surfaces. So see what I mean? If you lay these out properly, everything else downstream goes easy. And then if I need to save this, I come over here and save that out as whatever file type I need. So that's one method. But you notice this is designed to draw your contours and then fill those with NURBS patches and then the grids or whatever. Sometimes I've had instances where I need less resolution. I'm just trying to fit the minimum amount of surfaces. I've had customers say this. I want to represent this the lightest weight possible I possibly can. So one method is, this is one thing that's neat about wrap, is you can go ahead and you can strip off the surface. You can throw away the grids, and you can come back, and you can shuffle. So I can come in here, and I can subtract, and remove, instead of making this panel an 8 by 8, I can make it a 4 by 4 or 2 by 2, right? But even if I go all the way down to a 2 by 2, it's still got 4 patches on each one of these. Maybe that's still not light enough, right? So that's where you can come in. I'm just going to remove all patches and remove all contours. You can come in and just draw patches. And what this will do, oops, go ahead and get rid of that. What this will do is allow me to just draw individual patches manually all around the part. So very similar. Now you'll notice the colors are different when you draw patches. There's some other things going on because it has to make sure these are four-sided. Okay, so we'll just draw our first one, and you'll notice greens are endpoints and oranges are mid, right? And then you can add and subtract points from there. So this, in this instance, well, all I'm telling the software is I only want 4 patches all the way around this part. And this is a method. It doesn't have to be for lightweighting, like making a nice lightweight model. Some people might just want to completely control and draw every patch on the surface manually like this. Um, you do you, but that's a lot. That's a lot of work. I don't tend to do it this way. Now, again, I presented the way that the reason why I would have done it this way, the reason why I have used this method in the past is because I'm trying to make it so lightweight that I'm basically telling the software just make 4 surface patches all the way around this part and then hit OK. Now all I tell it is fill it with grids. You see how lightweight that is? Now if I still want to raise that, I could just say 30 and get a little more resolution on it. You see this? I can go 60. Then I start to creep back up into the territory that I was before, right? Or I could go the other route. But remember, the lower I go, the less it's going to follow the shape of the mesh. So you gotta find that happy medium where this is where I want to end up and then fit my surfaces. So look at how smooth that is. It's not really capturing the texture, but maybe that's what I want. I've had customers say that nice low resolution mesh surface. So the way I tend to achieve that is by just drawing my patches that way and accept that. There we go. Now on the other end of the spectrum, there are times where people will want to draw their contours on the shape of the part. So we'll just go ahead and strip back. And high curvature areas like this, sometimes you need more patches on those areas. So in those instances, here's another workflow, another method that I will use to go about drawing this. So I'll go ahead and draw my contours, and I'll fast forward for this part because I don't think you guys need to watch this all over again. What I'm going to do is just take this patch structure that we have, like we used before, and show you another mesh method that uses extensions. I don't use this one as much, but I will use it when I need to keep resolution along edges. So this part doesn't show it the best, but sometimes you have large, big panels and then sharper edges you need to account for. So you would like to keep surfaces along those edges, right? So with this method, you would come in after you have your contours, and you can do it in the contours tool as well. As you can come over to this specify, and I can hold the control key, and I can define all of these, and I can change them. This is specified extended contours. So what we're going to do is all of these contours will get extended. They'll get offset in both directions and make like a sub curve network inside of the network that we have here. Now, because I drew them manually and I'm not following the flow of creating contours with the paint method, you'll notice that if I come in here and I turn these on, that it has the separator paint. So with that separator paint, you can actually come in and you can dictate how far offset this red offsets from the curve, and you'll see why I do that. So you can update that red paint and offset it out, and the offset of the curves is dependent on that and the scale of it. So you'll see here that I went ahead and I offset it 20. Let's see if it'll go higher than that, 25. Okay, 20 is the highest it'll go. And then you can even come in here and like switch over to the line tool and kind of paint on extra red if you need it to go farther offset from the sides here. But the idea here is when I offset that red paint, I can come over here to subdivide extend, and I can come over to extension and I can say to extend, and you'll see it'll extend about that distance of the red paint. And I can add like a factor to it. So if I want to say 3x and hit enter, it will offset farther. See? And it's basing that off of the red paint. So if I didn't have any red paint, it would be 3x off of that little line and it would barely offset at all. But this is kind of the way you do it. Now once I have that, now you see that it put all these extra patches along the edges, and you can come in and edit those as well and move them around and work with them. Not inside of the extend, but you can come over here and you can do it inside of your patch layout. So what I'm going to do now is go ahead and say construct patches, and you'll see it'll end up looking very similar to the first one, but in this instance what I'm doing is I'm just telling it to go ahead and now fill those panels. There we go. And actually, instead of using auto estimate, let's do this. Let's go back in that one more time. I'm just going to put some super low number in there. There we go. And then, of course, you could. So the idea here is, again, is adding extra panels along the edges and then the interiors. And then you would come in here and you would specify your 4 corners to fix this one. And you'll see it's a 2x2x2. And then I should be able to hit execute. Let's see what it does. If that still doesn't work, then you can come over to grid. This is a great example of how sometimes you need to toggle the fill method of the panel. And hit next, okay. And then construct your grid. Fit surfaces. So again, that method, right? You want to preserve extra detail on the edges. It takes longer, I will say. I try not to use that method because extensions and stuff are a pain in the butt to work with. Sometimes you got all these extra surfaces. But you can see how that method could work to, again, provide detail along the edges. And then from there, I didn't show this at all yet, but you can come in and do a 3D comparison between what you fit surfaces to. And again, we did really low resolution here, so you're going to have in certain areas right there, right, almost a half a millimeter different because we didn't really add that much resolution to this. But you can see it's still pretty darn accurate considering how low we set the resolution on this. So those are a few different methods for surfacing inside of wrap. We didn't go super deep, but it gives you the highlights of something to work with, and then from there you can dive deeper into the tools as needed. So thanks a lot for your time.